All right, so thank you so much, Satish and Suven, for joining this session. This is the Future of Work session where we'll discuss about how the industry is changing, how the workplaces are changing, what's the latest advancements and developments in the field of robotics, physical AI, and things like that. So, joining us today, we have two exceptional speakers and industry experts. First, we have Satish Shukla, who is the co-founder, and the chief human resources officer at Adverb Technologies. Satish co-founded Adverb and helped scale it into one of India's leading robotics and automation companies, powering global warehouses and factories. He has led talent, culture, and capabilities building across engineering, manufacturing, and customer success while evangelizing Industry 4.0 adoption in India and abroad. His focus area include human robot collaboration, future skills, building equitable pathways for youth into advanced manufacturing. And Satish frequently mentors students and startups on careers in automation and the future of work. Satish, it's such a pleasure to have you join us today.
Thank you, Devesh. Thank you for having us.
Also joining is Suyan Nandi, who is the DGM in the CEO's office at Adverb. Suyan drives advanced robotics programs and external collaborations at Adverb, spanning mobile robots, cobots, and AI-driven automation. He works at the intersection of product strategy, partnerships, and tech demos that translate cutting-edge research into field-ready solutions. His interests includes physical AI, human robot integration, and scalable deployment playbooks for logistics and manufacturing. He is passionate about helping students map skills to real industry roles. Soven, thank you so much for joining us today.
Thank you, Devesh.
So, before we get going, a very quick overview of what we do at Futurowise. The Futurowise is a future readiness platform where we help students develop future readiness skills. Uh, we are running programs in robotics, physical AI, cryptocurrency and blockchain, design, environment, and sustainability. Your students can apply to us and they can register for one of our programs on our website, which is futurowise.com. And I'll share more information about that uh, during this session. But let's quickly jump into the question straight away. Yeah.
Sure.
So, Satish, my first question is to you. It's about robots and the physical AI. As robots and physical AI systems enter workplaces like logistics, healthcare, and manufacturing, which jobs are most at risk and which new roles do you see being created?
Sure. So, as Devesh, you mentioned about Adverb and our background, we will be taking this question from the perspective of physical AI and robotics and not the Gen AI and the other things that are going on. So, first of all, physical AI is basically robotics that is learning from its environment and evolving. So, like a computer program, you cannot you program for a certain number of use cases, but with physical AI you cannot program for the natural environment in which the robot is supposed to operate. So there the robot will operate in more of a natural environment and will be taking feedback from different ways, like, through different sensors, through different accelerometers. It will be taking input through vision, through camera, through lidar, through proximity sensors, etc., and different types of mechanisms, and will be making sense of its environment. So I will be restraining my answer from a physical AI perspective. So what I feel the jobs that are at risk of being automated is dull, dirty, dangerous. So any jobs that are dull, which means basically are repetitive in nature, which are dirty, which involves risk, which in so which in so dangerous would be risk. Dirty would mean which is not very hygienic in nature or which involves a certain amount of abrasion. So taking the perspective of logistics, carrying tasks, carrying objects for longer distances, picking up items, lifting items, uh, picking, packing, shipping, sorting. These are the kind of jobs that will be replaced through physical AI, like humanoid or quadruped or general purpose robots, as we call them. Uh, Now, what kind of jobs will be created in this new era, right? So, any job that requires creative skills, critical thinking, and eye for design will be will still be required in this era of AI as well. And there would be new jobs that will emerge. There would be people who would be required to maintain these robots. There will be people who would be required to visualize how these solutions can be implemented, right? There will be caretakers, right, which will be physical AI or humanoid. If we take a very distant view, there will be care. So just to take an example, there will be caretakers who will be robots, humanoids, etc. And there will be people who will be required to oversee these humanoids and how they are interacting, to sort of ensure a quality control, and to also ensure, in case of any subjectivity, how to take care of the scenario. So you can understand, wherever there will be edge cases, wherever there will be creative decisions that will be required to be taken, critical thinking will be required. Those jobs are going to continue to exist. That's what my perspective is.
Thanks so much for answering that. You said caretakers, and caretakers can be a human caretaker taking care of other human beings. And then you said that caretakers for the robots, right? These are
Yeah.
technicians, these are people like
Yeah.
that. Do you
Maintenance
already have
staff.
some of those roles in the
Yes.
industry that you
Yes, so
work?
those roles are there. I think those roles are going to increase, and you will see a lot of hobbyists also entering this space. Just like we have motorcycles, right?
Yeah,
So see, we have to visualize how economy will play out. So today there is a motorcycle OEM or there is a car OEM. Then you have somebody like a Big Boy Toys, right? Who modifies these cars or
yeah,
motorcycles. Then
yeah,
you have passionate people who sort of galvanize or who sort of add more metal on these equipments, right? And then there is maintenance staff as well. So today what we have is more of maintenance staff who are doing breakdown maintenance, etc. But when we will have all these robots, there will be a lot of new business models that will evolve from these robots, right? There will be customizations that will happen. There will be some customized use cases that will be required, right? So there will be, what will also happen is, there will be a lot of, so one more view that will happen is that since humanoids and general purpose robots will become very common, physical AI will become very common, we will again enter the era of what used to happen before industrial revolution, right?
yeah.
There were skills which we call vocational skills today, or artisan skills, that will become very vogue. So probably there will be a huge demand for an in-person physio, right? There will be a big demand for an in-person psychologist, right? So these demands will become very niche because a lot of these jobs will be done by robots, correct? So that's
Yes.
where the economy will
Yeah.
move eventually, and new jobs like these will be created.
Yes, absolutely. What I also think on this is, like right now, calligraphy is something which you have to learn specially. Earlier, people used to write by themselves, and calligraphy was much more accessible.
Accessible.
Yeah, but now you have to have a specialized teacher who can teach calligraphy to students.
So
Yes.
that's very true. It is so difficult if you want to actually write a handwritten message to someone.
Yeah.
It is very difficult to find somebody who can write it on an A4 paper without any rework or in a single go. But that was not the case 20 years back, right? So
Absolutely.
and if you just get an A4, if you get a personally written message by someone, the kind of impact that it creates is very different compared to a printout. So that's how the economy will also evolve, and that's how the jobs will also evolve. Today what is happening is a lot of manpower is required for jobs like data analysis, etc. I think that is something that is at a big risk,
Yeah.
even with physical AI, where you would not need people to do jobs that require basic analysis, etc.
Okay. Okay. That's great. So when let me come to you now. Let's talk a little bit about adverb. Adverb is seen as being at the cutting edge of robotics innovation. What are some of the most exciting projects or technologies that you are working on, Suven?
Yeah. So, so when we started in the year 2016, we were focusing. So since then, we have been focusing basically towards warehouse automation and logistics. So AMR, which is autonomous mobile robots, and AGVs, which is automated guided vehicles, were one of the first products which we developed. So the recent developments which we are doing in that path is like we are making it completely autonomous. By autonomous means it has the capability. So as Sir was saying, as Satish Sir was saying regarding which is called as multi sensor or multimodal fusion. So in generative AI, we have multimodal input in the form of like today's in GPTs, you put inputs in the form of text, in the form of images, in the form of videos. Right. In the same manner, in physical world, you put inputs in the form of say audio inputs or camera vision inputs. So I'm drawing that analogy here. Uh, then we have perception. So what we do is that we are building perception of our robots. Okay. So in terms of so how we had different industrial revolutions, right? In the same manner, we had different robotic revolution also. Okay. So the first robotic revolution was industrial robot. Okay, which came in the 90s. Then came collaborative robot, which is basically those robots which are safe, which are safe to work in collaboration with human. So at Adverb, since 2021, we have started building collaborative robots as well. And then the third industrial robotic revolution is basically those collaborative robot in a platform. So basically, those collaborative robots to be on a AMR. That means ki this robot can pick from one place, and this autonomous vehicle can go from one place to another, and there it can drop it. So this is the third robotic revolution, and we are building that as well. And the fourth industrial robotic revolution, which is basically to develop cognitive skill in a robot. What I mean by cognitive skill is basically so first thing is perception. So these kind of mechanical bodies should be able, or physical bodies, or we call it physical AI or embodied AI. So these kind of robotic things should have skill to perceive environment. By means sensor, then we have IMU for accelerometer, gyroscope. Your phone has tons of sensors, right? In the same manner, our robots also have sensors. And then we use something which is called as edge AI. So recently you might have heard from NVIDIA, there are edge AI devices like Jetson Nano, Jetson Thor, which is one of the most powerful edge AI device. And then we have Jetson AGX, Jetson Odin. These kind of devices where these many sensors data can be computed in real time. Okay. Which is basically inference. You are inferring from the data. And then basically OpenCV. So we use skills like OpenCV, which is Open Computer Vision software, where we have got lot of images, but what to do with that? How to perceive the environment based on that? That part is done, and then finally we manipulate the environment. So earlier, if you had to pick something from here and place it here, or we used to do fixed automation. That is, that object can automatically go, but it will only go from one place to another place. If it needs to go to another place, you need to put another set of, say, coding. But now it is flexible automation, where basically based on the perceived environment, based on whatever new data we are getting, it can go from one place to another without any new set of code. So it can perceive the environment, adapt to the environment, and then change accordingly. So these are some cutting edge technologies which we are working on based on the robotic revolutions.
Wow. So let me
Yeah.
just try to put it in my own words. Let's say the very
Yeah.
first one were the industrial robots, which were like
Yeah.
more basic ones, let's say. Then you came up with
Yes.
collaborative robots, which could work
Yes.
with humans or maybe with other machines.
Yes. With
simultaneously
humans, basically. Yeah.
with
It
humans.
has safety sensors around it. So it has basically something which is called as a fork stock sensor, which let it work along with humans.
Okay, which would prevent them from hurting us.
Yes,
Sort of.
yes,
The
yes.
third one, which is mentioned, was when a collaborative robot could work on a platform itself,
Yeah.
right?
In a
Where
mobile platform. So it can move, the robot itself can move from one point to another point.
Okay. And now what you are working on and what robots are evolving is now they have started having cognitive skills where they can
Yes.
perceive their environment and they are no longer have very fixed movement,
Yes.
but they have more flexibility, agility, and are more independent in some ways. Yeah.
Yes, yes. They can adapt to the environment, basically. They can think of their own, basically. That cognitive skill is that. Yeah.
Okay, and this is what physical AI would mean, which means that
Yes,
they can adapt and they can do things
yes,
by themselves. If you know
yes,
and you were talking about multimodal fusion, which is where they can listen, they can see, they can feel things like that. Am I correct in yeah?
yes,
Okay, okay,
yes, yes,
that's
yes,
very
exactly.
superb. Uh, Thanks, and let me come back to you, Satish. Let's talk a little bit about uh, the future for the students. Many students fear that automation will take away jobs and opportunities. How should they think about robotics as a threat or as a tool for their future careers?
Sure. So before I touch on that answer, so when he joined us, he was working on a project to replace the bartenders. And this was a project that was very close to Suvayan. So probably with physical AI, he will be able to replace all the bartenders. And then probably the demand for human bartenders would be remaining would go up. So, on a serious note, I don't think that there should be fear among students for automation. So there has to be a certain amount of fear, at least in mid-level professionals for robotics and automation, but certainly not for student because they have enough. Because see, it is a new field, and since it is a new field, it's a level playing field for everyone, and their curiosity is going to create a lot of edge. So if you see what happened with the era of internet, so if we go back and if we see and if we take, okay, Walmart might not be the right example, but if you see Walmart, they added stores one by one. He was at a particular age, he started, and then eventually he became a big entrepreneur and a billionaire, right? But with internet, what happened was there could be a student, proverbially a college student, who could be sitting out of a garage and could run big companies like even America Online, etc., out of business. So that's the kind of force multiplier uh, technology is, right? And I think the group that will benefit the most from it is going to be school and college students because they will have ample opportunities to experiment. The cost of their experiment is going to be too low because there is not a job at stake or there is not a livelihood at stake, but the risk reward ratio is tremendously skewed in their favor because if an experiment turns right, what will now happen is that earlier it was only software businesses that were at the risk of disruption by students working out of garages. But now even the hardware businesses will be at the risk of disruption by students who are working out of garages. So you could take up any problem statement that you are passionate about. It could be manual scavenging, it could be a security application, it could be a defense application. And today, with the right kits, you have every resource available to you to make these experiments work. And I think we will see a lot of student based startups gain traction in India in the field of hardware as well. So that's the kind of force multiplier we are talking about.
Yes, I think that's very interesting. Software is always considered as it allows you to scale um, without much capital being invested, right? Once you have built the software, you can just sort of replicate it and grow. And Satish, I've always thought that, doing this with hardware would be very, very challenging. But on a larger scale, on a grander scale, and completely, on a different tangent here, where do you see India standing here? How, are we getting ready for manufacturing like, let's say, China or countries like that?
So to be very honest, we are we there is still a lot of distance that needs to be covered between us and, let's say, a China. And there are historical reasons for it. We were a agri heavy economy, agriculture heavy country. A lot of workforce was there in the rural area. In terms of skills, as a society, we have never encouraged skills, right? So we have
Yeah,
never encouraged electrical skill, mechanical skill, welding skills. We have always encouraged desk-based
yeah,
knowledge, which has served the country well for a knowledge-based economy, and we have excelled in services-based economy. But a lot of things need to change. And again, talking about where you said that for hardware you need a lot of capital, etc. Today there are technologies available like a digital twin or simulation through which you can bring the cost of developing a hardware significantly down. And that's where students, these are the skills that students can learn on. But I'm sure as more there is also a lot of focus in schools today, I understand, and in colleges on projects. We are now seeing that every college has opened its curriculum where students can do industry practice for as long as a full year. So all these skills are going to help us, because as people will get more exposure, they
yeah.
will choose hardware as an industry because it is inherently more exciting, more dynamic. And India will definitely move forward, and we will see some very good hardware companies emerging out of India in the near future.
Yes, let's hope for that. Uh, Suven, coming to you now, I want to talk a little more about students and
Mm.
skills that they should start building. What are some of the most important skills that students should start working on if they want to thrive in robotics and AI?
Yeah. Okay. So one very important skill from basically from school grade 11, grade 12 onwards, which they can touch upon is basically C++. plus plus. Okay. C++ plus plus gives you the concept of the object-oriented programming, which is very important even going ahead. So and also more than the syntax and the language, it is about the basically the algorithms which are more important. So algos have always been more important. With the development of AI, syntax is something which has become irrelevant. So regardless of whether you are, whether you are doing C++, C Sharp, or whether you are doing Java or Python, but C++, the concepts, the algos which are taught in C++ are very important, and hence the next step would be ROS and ROS2. So ROS is robotics operating system, and it basically it gives you a package, a plethora of robotic related ability in a same platform. So you can just call libraries, and then most of the mundane jobs are there in the library, and then you can develop your application on top of it. Okay, so this ROS2 is something which one should go ahead with, and then they should try hardware in the loop. So what I'm saying is now, earlier the cost of robotics or getting these kits. So if you remember 10, 12 years back, it was Arduino, which you could buy for say 400 rupees, 500 rupees and work on them, right? And you could just glow one tiny LED, or you can run a motor, and that cleared a lot of it gave you clarity of PWM, it gave you clarity of digital input outputs and all that. But now, since the cost of robots have also gone down considerably, so if you see the college kits, those kits which are available are maybe not hundreds but in thousands. But you should do hardware in the loop. So maybe through some, say, through some educational institutions, or through some some online courses, or through some industry collaboration, somehow you should include hardware in the loop, because uh, so so what we do in robotics, what kind of skills are required, as you asked. So first thing is that you should learn these kind of in ROS, those packages. And then you will learn about RLMPC, which is reinforcement learning, model predictive control, where you will train the robots. Okay, so what you do is basically you leave a robot in an environment and you train the robot to basically learn itself in various environments. And then you can do a lot of things in simulation, but you finally need hardware where you do this something which is called a sim to real, where you get real life challenges. So friction, your maybe side, maybe the feedback from the motors. Those things cannot be emulated or simulated. For those, you need hardware in the loop. And then right now, knowledge of computer science along with maths and physics is something very important, because unless until you have knowledge of math, any kind of machine learning or deep learning, those kind of algorithms, you will not be able to understand. Okay. And without the knowledge of physics, robotics on a long run, you may be able to use robots, but you will never be able to develop robots. So maybe you might be able to use robots and do some application with the robots, but maybe code a robot, but you will never be able to develop a robot or develop a physical automation without the knowledge of physics. So I believe these are the core skills. Apart from that, I would say if it is about less, like if it is grade 5 to 10, if you're talking about those students, then Scratch programming is something they can do. And in college, again, Rust is very important. Python is important. Then they should learn about not only single robots, but there are various protocols. So there are various protocols like communication protocols. So how one robot communicates with another robot. So those kind of things, if somebody is in electronics and communication, so basic electronics is very important. How does a MOSFET work? How does a gate works and all that. Then I would say parallelly, ethics is very important. Machine safety, AI ethics. So which kind of job we can leave for AI to work independently? Which kind of AI jobs you need a human in the loop. So very early we started that in courtroom justice can be given via AI, but there you need a human in the loop because there are edge cases. So those kind of things. So there are various machine safety directives. There are many jobs also, because as Sir said, you need caretakers for robots. So for those kind of people, you need ethics to be very important. You need to know machine safety law. So like industrial robots have something which is called a 10218. Then for military standard, we have JS Penta 5. For collaborative robots, we have ISO 10536. Then for all other various things, you have these kind of directives which are very important, and that is also something which somebody, if they want, but it is similar to basically doing law in the field uh, of robotics. Yeah.
Super, fantastic, Suven. So, C++, I think that's where everything starts, and I think, when we were in college, C and C++ I think were the very basic, most important
Yes.
programming languages that we were asked to learn. Uh,
Yes.
Having an understanding of that definitely helps. Understanding of algorithms is important.
Yes.
Then you also mentioned about ROS, which is like the robotics operation
Operating system.
Robot operating system.
robot operating system. You mentioned about hardware in the loop. Now, can you
No, not hardware in the loop. Yes.
can you just elaborate a little bit more on what that phrase means, hardware in the loop?
Okay. Okay, I will explain you with a small example. Okay, today you can open any say. Okay, you are digitally creating an image. Okay, now now you are creating an image of something. You asked AI, say this new nano banana trend is there, so you asked it to make a 3D model. It's becoming very popular. So you put there is a screen, there is a 3D image of a human being, and there are some boxes around it. Becoming very common. Now hardware in the loop is like, if you want to make a 3D model of a human, You put that in a 3D printer and you get an actual human 3D model. So is that accurate? So basically, whatever you're doing in simulation, testing it in hardware before mass programming it. So you're programming it. So basically, what we do, we program it for a robot and then we program it for multiple robots, right? So maybe Android phone, and then we are putting up a new update. But then you put it across the globe, right? Before that, you need to put it on a physical hardware and check that whether those real scenarios are getting tested or not. Because on simulation, though they are very close to what is actually happening, but there is still a gap which we call as sim to real. So to close that gap, you need hardware in the loop. Also, these kind of environments in terms of robotics have something which is called as a physics engine, which basically puts all the law of physics into the model. But still they are at 99%. That 1% is still left. So that you need to test in a real hardware. And that gives you the actual scenario that whether you have reached 100% of your product or say 99% of your product. So
Yes.
the Pareto rule applies there as well.
Okay. So what I take from this is you have
Mm.
built everything, you have conceptualized everything, you have built the system, you have built the coding and all. Now you're first bringing in the hardware to actually test it to see if
Yes.
whatever assumptions you have made, whatever coding you have done before replicating it hundreds of times. First, is the hardware able to execute all those rules, all those coding, etc.
Yes.
Does that make sense?
Yes,
Am I on
yes,
the
yes,
right?
exactly. Yeah.
Okay, wow. Fantastic. Thanks for sharing that, Suven. Satish, let's talk a little bit more about the global perspectives about, the positioning of India in general. From your perspective, what unique problems in India or globally is Adverb solving with its robotics and automation solutions?
Sure. See, globally, the problems that we are solving globally and India functionally remain the same, but the purpose is different. So, in the West, there is no availability of manpower. So, there is a demographic pain that the Western economies or Western or mature countries, advanced developed countries are going through, where there is no labor available to perform these jobs of moving material inside the warehouse, picking the material, packing the material, shipping the material. So that's where we are using technologies like ASRS, AMRs, sorting robots, etc., to automate these jobs completely so that businesses can run without any disruption. Now in India, the use case is different. Again, we are automating these jobs, but not to replace labor, but to ensure the business can scale fast in an efficient and cost effective manner. So these are some of the things that we are doing through our products and the problems that we are solving in India and the world.
Can you elaborate on the ASRS AMR? Like, what does that stand for?
So ASR stands for Automated Storage and Retrieval Systems. So you can store pallets or crates, which are basically blue boxes in which you see milk packets kept. So you can store material in those crates or on pallets, and you can store it at height. And there will be a machine or a shuttle system which will go and bring this material out from those storage systems. So these systems are called automated storage and retrieval system. When you have to store huge volume of goods, thousands of SKUs in bulk volume, you use ASRS systems. You use sorting robots, AMR, for point to point navigation solutions that you require, or from moving material from one place to another on ground.
That's very interesting. We are almost coming towards the end of session. From both of you, I would like to learn more about the future, about the next decade. How do you see robotics and physical AI changing the very definition of work itself?
So,
Whoever
so,
wants, yes,
so
Satish.
when you can probably take it first and then I can take it.
Okay. Okay. Uh, Thank you. What one thing which will change fundamentally is you will see a lot of automated tasks happening around you. And a lot of physical tasks, as we were discussing in the beginning, dull, dirty, and dangerous, all those tasks being replaced by automated bots. And the roles, so the jobs will changing from, role-based job to skill-based job. What we mean by role-based jobs, so earlier we had analysts, we had jobs like legal, we had jobs like marketing. Uh, but that will basically change with skills. Skills means maybe earlier a marketing guy needed to know a lot about how to present, or maybe fundamentally what is taught in MBA. But now those people who is good with using AI. So there is something which is called as prompt engineering, which is something fundamentally everybody should know. So prompt engineering is how you can expand your knowledge base, you can understand your customer, and you can change your marketing requirement, or maybe you design a lot of things, right? So those kind of jobs or those kind of individuals will be preferred more than, well, somebody, if you ask to fill a role of marketing, maybe, maybe it is expected that he will understand customer also, he will do some data science also. So one thing is that maybe Satish sir can tell more about that. And from environment perspective, as I said, lot of jobs will be automated, lot of your workflow will be automated. You might not be reading mail by mail, so you might be only reading summaries. And from the physical side, dull, dirty, dangerous jobs will be automated 10 years from now, is what I believe. Yes,
Superb.
over to you, sir.
Yes, Satish. Thank you so much.
Sure. So, in terms of next 10 years, I think there will be a humanoid for almost every human, just like we have cars. And that's going to be a very interesting world where new emerging business models will come basis this. What will also happen is today there is a lot of, in terms of work or in terms of academics, today, or at least in last 10-15 years, there's a lot of education that is siloed. So a software engineer will sort of be a software engineer. A mechanical engineer will be sort of be a mechanical engineer. In the last decade, if you see, we saw a lot of mechatronics engineers coming up. And even if you go and see the robotics engineers, these are engineers who are multidisciplinary. So we are going to see interdisciplinary folks, interdisciplinary students who will be preferred by the industry, because the nature of these jobs will require elements of both hardware and software. And I think that will be a big shift, where you will sort of, from the culture of taking specialization and then taking a specialization in specialization, you will sort of prefer generalists in fields like engineering as well, which was earlier the case with only management.
Superb. Thank you so much, Satish and Suren, for sharing your thoughts. Uh, I think interdisciplinarity is important. Students need to focus on being broader in their what they are learning, and not, of course, depth is important, but just learn more about different things.
Yeah, so sorry to interrupt, but there will still be people who would like to go deep in a subject because of passion, because of research. But there will be people who would, matlab, if there would be requirement for professionals who need to be generalist, need to understand the domain to a certain extent. As Suven has mentioned, some of the skills are like bare minimum. So in
Mm.
MBA, you would need to understand marketing, you would need to understand how to read a balance sheet, you would need to understand basics of operations, supply chain, etc. And then you could be rotated into any function where you'll sort of go deep into that function. So the idea is here also you need to be equipped with those skills, not knowledge, right? Not knowledge,
Yeah.
skills. And then you can sort of dig deep and do problem solving with those skills in robotics domain. So that's the kind of professionals we will see rise faster.
Okay, superb. Satish, I've seen you mentor students all your life. You've mentored juniors or sort of people that come across to you asking questions. Now, what advice would you give to young students, very little, let's say ninth, 10th graders, what should they be thinking about? What should they be doing right now? And it's, uh, world is going to be very, very different when they grow up. Uh, what should the parents of these kids be doing? These are 13 to 15-year-olds.
Sure. So two, three things, and this is just an advice basis how we have been brought up and the environment that we have seen around when we have grown up as adults. First is, so as you grow, your curiosity reduces, right? A 3-year-old or a 4-year-old will be more curious because they would be exploring and making meaning of the world around them, right? And our pedagogy is also in a way कि you have to prove Pythagoras theorem or you have to prove Archimedes principle in a particular way. So my personal suggestion would be to students or even to parents to not let that curiosity die, right? Let that curiosity be, because a lot of these fields are evolving and nobody can predict how the future will exactly be. If somebody is coming and saying with 110% confidence that this skill is going to be all, do all you need to have, or you will fail in life, that person is bullshitting. So be curious, and be curious to know why this skill will be required, right? What is the purpose that this skill is solving, and how can this skill evolve in the future, right? So that's something that students should focus on. Again, something that I am going to say will be an outcome of curiosity is learnability. That is applicable for all professionals, that is applicable for students as well. uh, be be very high on learnability, because that is something, because in your professional life, see, at the end of the day, you choose to become an entrepreneur or a professional or an author or a journalist, whatever it is, no amount of education can prepare you for the next 20, 25, 30 years. When we were studying, we never visualized that, okay, robots will come which will eliminate the jobs completely, or even as late as 2021, people did not visualize that chat GPT will come which will make writing articles so easy, right? And today it has completely changed, especially in fields like marketing, chatbots. This has completely changed the game, right? So that's why developing learnability is very important, right? You need to develop that as a skill, as a competency. And one more thing that I would urge parents to inculcate in students 13 to 15-year-old is the quest for experimentation. So they should be open to experiments. There's a very long life ahead of these kids. They should not think in blocks that, okay, we need to take this, then we need to do engineering, this is the only way to succeed, etc., etc. Let them be open to experiments. And this is something which we have seen in the West work, where people even go to the extent of taking a gap to decide what works for them, and they take a lot of experiments. And there this model has typically worked, because there people tend to find their passion because they are experimenting a lot. And this is the age when, the again, as I said, the risk reward ratio will be skewed in the favor of students. As they go higher up, the parents need to understand, as they go higher up in the age, the risk reward ratio goes against them. So this is the right time to experiment and really try and find their calling.
Wow. Curiosity, don't let that curiosity die. Parents, I think that's most important. Develop
Learnability.
learnability. They should have a desire to learn more, learn new things, and let them experiment. I think at an earlier age, at a younger age, experiments has lesser risks. As they grow older, I think the risks increases. So the sooner they start experimenting, the sooner they have, the sooner they can get excited about new things and experimenting with new things, the better.
And
Uh,
just to add evidence to this, right? So Bill Gates, who started Microsoft, was one of the rare students whose school had access to computers, and he was allowed access to those computers, right? Similarly, and I was reading just few days back that Mark Anderson, I think I've got his name right, who was the founder of Netscape Navigator, which was like the most valuable internet explorer, internet browsing companies in the world, got access to computer at a very young age and was allowed to experiment and create software programs, right? Then again, there are companies which have built lidar, right? And I'm forgetting the name of the company. It just got listed 3 years back on Nasdaq, and the founder was given the leeway by his parents to make a hardware from video game. So the video game that the founder had, he wanted to make some hardware out of it so that he could play with that hardware. And his parents said, okay, go ahead and do it. And this was as young as an 8-year-old. So there is credible evidence that if you allow kids to experiment and fail fast, they will eventually find things that they enjoy and then they can go deeper into that.
Such a fantastic piece of advice, Satish. I have a couple more questions here.
Sure.
And this is a very unique, very interesting. Do you see colleges losing relevance? Do you see that the formal education, the university education will lose relevance? Yeah. And if yes, then in what time frame?
Sure. So, Suvyan, if you would like to add on it, and then probably I can weigh in.
Okay. Thank you, Satish. So, uh, see, formal education is always required because, however good a student is, if his basics are not clear, maybe in a short run he might excel, but in a long run he won't. Formal education is important. And also, I saw a few questions which says that whether computer science is more relevant or robotics and automation is more relevant. uh, this perception itself needs to change from students perspective, also from parents perspective, also, that which major they are joining. Because when we also go to college, and because Satish has gone to many more colleges, he can also support in this, or maybe he can agree or disagree to this. But when we go for a computer science student, we look for what extra capability he has, not the basic computer science which he has cleared. Because in front of us there are some 59 pointers who are there. We never look whether what they have done in computer science. That time we look what extracurricular or what kind of projects they have done. So even in the West, if you see the course, the basic courses are like very less. So if it is a say 4 credit system, maybe credits equivalent to uh, 1 credit out of 4. So 25% is the basic which they join. So which is like computer science. And then a lot depends on what kind of electives they take, because the plethora of subjects which they know and the kind of projects which they have done is much more important. So coming back to these kind of questions, or whether college will be relevant or not, college, as I told you, hardware in the loop, I told you physical AI. So all of this, college gives you an excellent platform that for that. Okay. As and when, because even with physical AI or even with generative AI, you need access to GPUs. Okay. Those are costly. So you need a formal education, you need a platform where you will get access to these kind of infrastructure, in these kind of hardware, these kind of professors, this kind of what is happening new, these kind of, say, maybe only college students will be able to go to these kind of challenges. So those are very important. Apart from the fact that you are going to college to gain a degree, we should just lose that perspective in mind. We should think that okay, कंप्यूटर साइंस मिला है, ले लेते हैं, बट उसके बियॉन्ड क्या करेंगे? That should be the perspective, even from the students, even from the parents' perspective, that physically, but that those BTech things doesn't matter anymore. That's what I feel.
Yes.
Over to you, Satish.
Yes.
Sorry.
So when what I take from this is a formal education is important,
Yes.
but you should also learn how to apply the learnings, right? Number one.
Agreed.
Number two is don't worry just about the degree. Focus more on the learnings and the applications of your learnings. Satish, over to you. Yes.
Sure. So Suven has captured a lot of things that I would like to have to add there. So see, what usually happens is that there will always be edge cases in society. So there will be a Steve Jobs, there will be a Mark Zuckerberg, or a Bill Gates who would drop out of college and still go on to be successful. But then probably these kind of people never needed an institution like that, right? And probably they are very brilliant. And they were brilliant and they didn't need an institution. But the role of institution is to bring people with sort of different aptitude levels. At school, it is completely random. Okay, you have entrance tests, etc., but it is also a function of where your parents are living, uh, what kind of schools are available, and decisions like that. And in colleges, it is more homogeneous. But you see how the institution is evolving. You have a heterogeneous group where people with different backgrounds, different interests will come study with you. Then you go to engineering. So, in a structured way, you are being exposed to different facets of life, different facets of skills, different facets of what you want to do in life. And then you can sort of take a decision what I want to do or where I want to grow. Right. And then in college, also, as Suvyan has mentioned, and somebody had asked, should I do computer science or robotics and automation? See, if I have to give a crude answer, obviously go for robotics and automation because it's more multidisciplinary, what we were talking about. But again, this should not be the lens from which you should look at. You should look at the kind of peer learning that you would have in that course or in that college. What is the kind of other life experience? See, you have to understand that, as Subir has mentioned, apart from infrastructure, you will get a very secured environment in these institutions to experiment, right? Where even if you fail, the consequences will not be very high. At most, you'll be repeating a semester, right? Which we realize in our lives is one of the, if you ask me, this is one of the least amount of risk. If you go become an entrepreneur and you fail, you actually lose out on every financial security that you have, right? Or if you start failing in job, you'll eventually be out of job and you will start thinking, how do I get money so that I can eat next? Compared to that, failing in such structured environment is actually nothing. It's just a life experience, right? Which will not even impact you 10 years down the line in any way. So that is the role of these institutions, which is going to remain. Probably the pedagogy will definitely change. Opportunity for people to break off from the institution when they feel that the time is right will be more flexible, which we are already seeing. As Suvir has mentioned, even in Indian universities, we are now seeing where people are studying economics, history, and computer science, right? So these kind of combinations were not available 10 years back. And these kind of people are coming up with ideas, solutions, which are really groundbreaking. So that's just to give you a simple example, there is a company called TVF, right? And all those are engineers from IIT, right? And they have gone into creative drama making and all these things. So that's how it typically is going to work. Institutions are going to give you experiences basis which you can choose what you want to do. And if you hear the interview of these guys, they say we were in the drama club of IIT Kharagpur, etc., and that's where we learned acting. So this is so there are people who have gone through NSD, National School of Drama, and have learned acting. There are people who have gone to IITs and have learned acting. So the routes are different. So that's going to continue to remain.
Wow, fantastic advice, Satish and Suvyan. I think it's time to close now. While I would love to continue this conversation and ask you many more questions, but in the interest of time, I think we need to close. We are running a program with Adverb on robotics, and I invite you all to check that out and register for it. We'll have some exceptional speakers joining us and talk about the future of work, the future of robotics, industrial automation, etc. Let me just very quickly share our website and show to you what all programs you can participate in. And then after that, Satish and Subin, I'll just ask for one final tip from both of you to the students. So let's hold on for that. But students and parents who are here and counselors, you can check out our website and you can register for some of these very exciting programs which are coming up in the next few weeks and months. We are going to be talking about the factories of the future, principles of design, cryptocurrency and blockchain, public speaking, ocean and space exploration, carbon credit training, trading, business valuation, astrophysics and astronomy, and agricultural technology. So these are some of the things that we believe would be important in the future. And I encourage you to look at some of these programs, so that students can start exploring and developing and building some of these very important skills for the future. Back to you, Satish. Suvyan, one final piece of advice for the students, and we already have a counselor, Vanna, who's asking how can students intern in your company. So
Sure.
maybe.
So they can reach out to HR, drop their resume on website, and if we have a position available, we will definitely reach out. We have done this. Just one piece of advice: there were a couple of questions we could not address because of paucity of time. That only 5% of colleges add value in India, or people look for jobs uh, oriented courses. So all the courses today, and I can tell you any course that you can think of which is not job oriented will definitely have a job, right? Today we have seen that these kind of jobs never existed. So let's say you take public admin or a political science as a subject if you're passionate about it, and today you can become an influencer with just a mobile, right? So, and that's also a job. So a lot of time we classify certain jobs and we try to think that, okay, is this education going to give us that job or not? So we need to come out of that mindset. At the end of the day, in terms of adding value, I'm sure this number would be only a little bit higher for a lot of foreign universities and countries as well. At the end of the day, it depends on us. What value do we make out of the opportunities that are given to us? So that's the final thing that I would like to leave with.
Yes, absolutely. Fantastic. Thanks, Satish. Suvyan.
Yeah. So, my final tip would be more towards entrepreneurship, or if somebody wants to start something new for young innovators. So, if you see historically, if we compare, so if you see Steve Wozniak, who created the computer in his garage, or Mark Zuckerberg, who one day just woke up and thought ki, he will correct Harvard's this student cataloging system, and from there he started Face Mesh on Facebook. So it's about one crazy idea which can change the world, and it can happen at any age. So people, okay, I know we are thinking about formal education and everything, but parallelly, uh, the education system, okay, so it's more about what being taught and what you learn. So the learning side is like, look from that perspective of finding something revolutionary rather than trying to fit yourself with what is there. Maybe that will add more value to the system, to the individual.
Wow,
Yeah.
superb. So try to find something out of the box instead of trying to fit yourself in whatever is already available. What a fantastic session, Satish and Suven. Really enjoyed listening to both of your thoughts. And I mean, there's so much learning for me. I made lots of notes and learned a lot of new things about robotics, about education, about the future. And I can already see counselors and parents thanking us. So thank you so much. Really thrilled about taking this to more students now. Thank you.
Thank you. Thank you, Devesh, for arranging this. Thank you.
Thank
Thank
you,
you.
David.
You. Bye. Bye.
Bye bye.